I'm Chavi Bhasin. I'm Senior Program Manager with Microsoft in the Azure Machine Learning group.
Hi, and I'm Jakob Spoelstra. I'm a Director of Data Science in our customer client, what do you actually call it? Call it the Customer Engineering group.
And we are here today to walk you through a session on model management and deploying models into production. So 3 years back, we announced the Azure Machine Learning Studio. It was a browser-based experience, or is a browser-based experience, that allows data scientists and machine learning enthusiasts alike to build their machine learning experiments in a very easy drag-and-drop way. It just as easily allows them to deploy these models into production. We supported the batch as well as the real-time web services in production. And this week, in fact, yesterday, we're proud to announce additions to the Azure Machine Learning product. We announced the experimentation service along with the workbench, which is a code-based experimentation framework that allows you to prepare your data and train your models at gigabytes, terabytes, petabyte scale. We also announced the model management service that allows you to easily deploy your models as Docker-based images. Along with that, we provide the model management capabilities in production. So going into the agenda, we're going to talk a little bit about the AI lifecycle, how that differs from the regular software development lifecycle. We'll get into some of the learnings that we had from Azure Machine Learning Studio, and then a little more deep dive into what matters when it comes to AI in production. What are the table stakes? What's specific with machine learning or AI? We'll dive into the model management service and the capabilities that we're offering, the what, the why, and the how-to with our service. We'll talk about the deployment targets, table stakes. We'll talk about how we handle latency and scale for production-based scenarios. And then we're going to go into data drifts and data pattern change detection using a fraud detection or a risk detection scenario. And a quick wind-up after that.
Okay, so let's start talking about kind of like the life cycle of models. So what we're showing you right now, this is a typical software development process, and should be very familiar to the guys who are developers around here, especially these days with the continuous integration, continuous deployment, right? You're basically going through a build phase where you develop your software, it gets deployed into some kind of production, and then you're monitoring it and you're debugging and releasing, you're doing new releases all the time. So when we go at so for a data scientist, there's a very similar pattern emerging these days. So first of all, if we look on the left-hand side, the modeling side, that's usually kind of like the machine learning side of the house. We have phases where, and there's a cycle that usually starts with understanding some business requirements. Then there's a data phase. We acquire various data sets. We analyze the data sets. We get to understand them. Then there's a modeling phase where we actually start applying machine learning models, and we come up with usually some kind of predictive model, something like that's ready to deploy. There's some evaluation and testing. And once that's ready, and usually, this is typically more circles with little eddies where you repeat lots of those steps, then you get to the release side. So once you get to the release side, this is where you then have to, let's go this way, you actually usually hand it over to someone who then has to take this thing and put it in production, right? So there's some similar concept then of having to deploy the service so it can be used in a service. So for instance, it's scoring transactions for fraud or something similar. This needs to be operated, and the same thing, it needs to be maintained, and then usually then the circle repeats, right? At some point you get the data in again. Although these two are very similar, the data science part is different from software in the sense that models as an entity have unique characteristics, right? There's the data that was trained with. You need to keep track of the lineage of the data. Models have several iterations. You need to know what parameters were used in the different models. Then you try a model. You have several versions of the models. You might pick one you want to deploy. Once you've deployed, you might want to switch them out to do some kind of A/B testing and the like, right? So there's a lot of almost like version control type activities that happen with these model objects as well. So in our talk today, so we're going to really focus on the right-hand side. We'll touch a little bit on the modeling side of things using the new Azure Machine Learning, but the focus really is on this life cycle of deployment of a model. Okay.
So when we released the Azure Machine Learning Studio, back then, our aim was to democratize Azure Machine Learning. We got great traction. Our customers loved us. We got a lot of feedback from our customers as well, and we have listened to that feedback. We've incorporated that feedback, and that's where we are releasing these new services that we call the experimentation and the model management. Specifically, when it comes to feedback from the data scientists, one of the things, in fact, one of my data scientist friend mentioned, that we're like chefs. We like to touch and feel and smell each of the ingredients that go into our recipe. We want more flexibility. We want more control. We want to be able to use the IDE of our choice. We want to be able to use or leverage all of those open source libraries that are out there for machine learning. On the deployment side, enterprises have told us that they want to be able to add additional code to their prediction services. They want to be able to have multiple models behind the same web service. But they want, in terms of the ease of use of deployment, they want just as easily to be able to deploy their web services in production. Beyond production, there are other capabilities that they have asked for that we have also incorporated. With regards to the IDE of choice, the open source libraries, and the ease of deployment, I'll give it over to Jakub, and he is going to walk us through some capabilities.
All righty, so we're on to a live demo, which is always fun. All right, what you're looking at right now is the Azure Machine Learning Workbench. This is the desktop tool for doing Azure Machine Learning. And what I'm going to do is to demonstrate the deployment. I'm going to use one of the examples that come with Azure Machine Learning. So just a quick recap. Basically, you create a new project by clicking on New Project. And that you have to fill in some information. And one of the examples here is the iris data set, and that's the one we'll be using. I'm going to use one that I already deployed to make sure it happens fast. There we go. So the iris is actually an interesting data set. It's a data set that was introduced in the 30s by Ronald Fisher, and kind of to demonstrate his linear decision algorithm, and that was basically, so that kind of started almost like the decision science, right? The ability to discriminate between classes. So this is a data set. So let's look at the data itself here. So if you go to the data, I'm choosing the data tab here, and I'm selecting the iris data set. So this is a data set that you can see we loaded from CSV. It contains 4 numeric columns, and I'll go in a little bit to show what those are. Those reflect various characteristics of these flowers. And these irises, there are different irises. This is a text column. This is what we were trying to predict. One of the features of Azure Machine Learning is that you can very easily deal with data and manipulate it. So by clicking on this prepare, and I'll show you just what I'll do, this allows you to kind of manipulate the data, and you create a flow, something like this. And if you look at the steps here, what I've done, I'm not sure this might be small on the screen there. Let me show you. I've essentially started with a reference that a data set that I've selected, sampled it, and renamed some of the columns to more friendly names. So this gives me a more clear data set to work with, right? So I know what my columns are. I can look at the species. There's some very easy ways to do. I can get more detail on the data by, for instance, let me just see what do I have in terms of classes to work with. I add this, and I've got a very quick histogram on to see I have 50 examples of each of these classes. All right, so that's the data bit. Now I want to actually go to train a model and deploy it. So the first thing shall we mention as well is the ability to work with our own IDE. I happen to like Visual Studio Code, so I picked that as to open the project in. And so it opens up Visual Studio Code, and we're looking at the Python files. You can see all the file assets that we have here on the side. And the first file I'm going to show you, this is the uses scikit-learn to train a model. And it's pretty standard scikit-learn. The first difference you'll notice, like, all right, where do we get the data from? For those of you who've used it before, you might be expecting something like a load CSV or some similar command. In this case, you'll see that we do a run, and we run a data flow, right? So what this actually does is that previous manipulation where I actually took the file, renamed the columns, and did some things, that creates Python code that you can actually run as part of your model. So by calling this run, it actually returns to me a data frame, and I can use this for my modeling. Something else you might note in here that's different, you see this run logger command. What this will do is allows us to kind of keep track of some parameters and results of our model. The other thing is, all right, so once we've trained, you'll see that this is the standard, we're training a logistic regression model. We log some of the accuracy results. And then once we're done, you'll see that we actually save the model into a folder outputs, and it says model.package, right? So essentially, so what this file will do is it'll read the data from our preparation, train a model, save the outputs. Okay, so let's go back to Azure Machine Learning, and we can now go and say, okay, let's execute this model. In our execution, we've got a few options. We can run on Docker containers, remote, locally, and the like. I'm just going to run this local. I pick that I want to write this iris scikit-learn, and I click on run. So running this will submit the job, and we can keep track here of the running of the job. And this one should complete in about 10 seconds, so let's hope this happens. There we go, done. When it's done, we can click on it to see, well, what is the results of the run, right? So it keeps track of the actual running of it. You'll see these numbers here, the regularization rate, accuracy. Those are some of those values that we've logged. So we said we wanted to log and keep track of that. Other outputs here are produced as part of the file, so you can see we can also bring down images, anything. So this is being kept of us. So this looks like a normal run. Cool thing about this is that it actually, these runs are kept in a history. So I just want to quickly show you here. So I've actually done this a few times, practicing for this talk. So there's all the previous runs I've done. And this keeps, if those numbers you just saw as a single number, we now show you a graph because we're looking at a number of runs, right? So we've actually run this 15 times. And I've tried different numbers of this regularization rate as I ran it numerous times, and it gave me different numbers of accuracy, right? So very quickly I can see all the runs. I might decide, okay, this looks like a good one, so run number 20. So I can go here and say, okay, just show me the details of run number 20, and I have the results. So for all these previous runs, I have all the results. Remember that what this model produced was this output model package. I pick the package, and I can say, let's download this package. And I'm going to save it in the same place here. And I'll replace it. Okay, so what I've now done is I took that model that got produced, I downloaded it to my directory that I was working in. The next thing I want to do is, all right, I now have a trained model. I'd like to deploy it. So in order to deploy it, we need to produce a file that the deployment service is going to use, right? This file has two important components. The first is this init, it's an initialization. This will run only once when the service gets launched, right? Typical task there is load the model. And if we ignore some of the other things here, basically you'll see that the init says, where do we go there? This is actually the wrong place. The init function says load the model, right? That's all the init function needs to do. The other function you need is this run function. The run function is going to receive a data frame as an input, and it needs to process the data frame and produce an output. So you can see here it receives the data frame. It actually runs the model.predict, that's the standard scikit-learn function, and then it returns a JSON string as the output, right? So the init function initializes once, run function runs again. There's one trick that we have here. The main function is just for testing, but we actually use it in this case to actually test the function by sending it some data. We also have a function which we provide, generate schema. So in order to produce a service out there, you need a schema so it knows what data to expect as the web service. So we've got a function that if you give it the run function an example of your data, we'll produce a schema for you. All right. So this is the contents of the score function. So we can go back here and then say, well, let's go to the dashboard. We'll run local, and we'll actually run the score function. So again, this just test the actual service scoring function which we produce, which we want to deploy as a service. And this should be finished in a few seconds as well. So let's give this a second. Right, it's done. So we can look at the outputs and the schema. This is the schema that we wanted, so we'll download the schema. And I'll save it. And actually, I already had one, but that's good. OK, so we actually have everything we need to deploy a service right now, right? We have a scoring function, we have a model, we have a schema. So we'd like to deploy this in our Docker containers. So I'm going to demonstrate to you the command line version of deploying. So what I do for that is I say, let's go there. Let's give us a PowerShell window. And we've got one which I've set the font of really big so you can read it. And I'm going to cheat a little bit by taking a command I've already typed before. OK. And this here is the command in order to deploy a service. So I'm going to run it while it's running just to see what's in there. So the command is AZ. So all the Azure commands start with AZ something. ML service create real-time. So we're creating a real-time service. But we need to give it a name, iris. We need to give it a model file, you see here. And we need to give it a score file. And then the schema. And we tell the runtime is Python. Your other runtime option is Spark, right? But we have a Python model. But basically, that's it. This one command is going to create the service. So it takes a few seconds. So while it's running, actually, I want to show you one more thing. Just as a quick tour here, we mentioned that you can bring in your own libraries. For instance, for those of you doing deep learning networks, TensorFlow is a very common and popular kit. We have some examples to show you how to run a TensorFlow model on the same thing. You can run these TensorFlow models locally. You can Docker containers. You can run them on remote VMs. If you have a GPU machine, you can run them on a GPU machine. And basically, what you need to do for that, we have a set of files in this folder called AML config. And you basically, there's a conda dependencies. So you can specify any external dependencies that you have in this conda config. Whether it's TensorFlow or any of the other specific packages. And this will get packaged up in your container when you create the image in order to deploy. OK, so this is still running, and we can give it a second if it takes a while. OK, I think this will take a few seconds, but I think in the meantime we can probably go on and we'll come back to this. All right, we switch over back again. Okay, let's go back to the deck.
So we need to make sure that the service is created for the next
one. Okay, I can check for that.
All right.
We'll check to make sure it completes while Shabby goes on.
All right. So what Jakub showed you was deployment in production, a very simple one command line deployment in production. But obviously, when we talk about enterprise scale deployment is just the beginning of things. There is the journey of how you get there. There's multiple teams involved. There are data scientists building the models. There are developers coding the prediction services or creating the scoring code. And then there are DevOps who are deploying these models into production. Besides that, there is the regular table stakes, everything that matters for any software that you deploy to production. We have to worry about scalability and latency. For systems like ad platforms or search engines, it's very, very important to make sure that those search results are delivered in real time at really, really low latency. Systems also need to make sure that the service is always up, it's always available, any updates are made, are rolling updates. We have to make sure that rollbacks happen fine. There's also the aspect of diagnostics. When the service is down, what went wrong, being able to debug and diagnose those problems becomes really, really important for anything software. Besides that, as Jakub was talking about, typically the AI production lifecycle, right? What's unique about machine learning models in production? With more and more enterprises now using AI to deliver insights for their business applications, more and more models are being deployed in production all over the place. There's, with changes in data patterns, which happen all of the time, there is a need for deploying retraining infrastructure. And this retraining infrastructure causes a lot of versioning of the models to be deployed and redeployed over and over again. There are other cases like A/B testing. Enterprises are doing a lot of experimentation in production these days. That results in a lot of versions of the models being produced. So all of these result in many, many, many versions of models that need to be tracked. The questions that come up with this, right? What are the questions that come up? What is the version of the model that's deployed behind this particular web service? If it's a multi-region deployment, every region, what are the versions of the models that are being deployed in region 1 versus region 2? ISV scenarios. There are a lot of ISVs that have one model that's trained on n different data sets for n different customers. That results in versions. That results in the need for version tracking for these models. If a model degrades in production, we need to find out what is that version of the model that degraded so we can go back, see what was the version that was performing better, and roll back to that particular version of the model. Our internal customers, internal partners have also been facing similar problems as they adopt more and more AI every single day. We have been working with them. They've come up with their own homegrown solutions as well. But what we are offering with model management in production is one coherent solution that we would like to evangelize, that we would like to prescribe for here's how you do model management. And this is what we want to be able to show in this next walkthrough. I'll be building on top of...
You want to go to yours?
Well...
You go to yours, okay. So by creating this service, it's almost done. Let's give it for a second or so. You can start working on the model, right?
Yeah. So what Jakub showed you was one model that he created. It was an iris model. I have a better version of his model. So there, I've gone ahead and created a model using the gradient boosting classifier, and that's what I would like to go ahead and register. Yeah. So here's what I'm using, and I've commented out, Jakub, what you have been using. I have already gone ahead and run this model. Well, actually, so before we go into this, actually, why don't I go into the concepts for this?
Okay.
While Jakub is creating his service, I want to walk you through how we are introducing model management. So the very first thing that you see here, this is a slide to explain the concepts. The very first thing that you need to do is go ahead and create a model management account with us. Provision a model management account. You can go to the Azure portal and go ahead and create that. Next, imagine that the data scientist has picked their model already. This is typically the .save that they do in their model authoring code. So that model is the one that you will go ahead and register with your model management account. Once the model has been registered, what are the next few steps, right? To deploy things in production, there is your model calling, your model load, and your model execution code to run those prediction services for incoming traffic. That's your code and the dependencies. So if we combine the registered model, the scoring code, or in Spark world, you call it the driver file, or any other code that has to be accompanied for production scenarios, any dependencies like your pip packages or your conda dependencies or your model configuration files, all of those, the combination of those, the declaration of all of that is what we call a manifest. So the first was go ahead, register the model. The next one was go ahead, create a manifest with information or location about your code, your dependencies, and any other configuration that you would like to accompany with you. And then the next is creating an image out of this manifest. So this is a Docker-based image creation. We're creating Docker images using or pulling down the assets that we see in the manifest file. That includes pulling down the model, the registered model, any code, any of those dependencies. That's a step 3. Register your model, build the manifest, or create the manifest, build the image, and then the next thing with the image is go ahead and deploy that to an Azure Container Service. So we are deploying these Docker images to Azure Container Service. Obviously, we have our own secret sauce on top of that. We provide our own model hosting solution. But this is what the concept is. Again, to repeat, register your model, create a manifest, build the image, and deploy. These are the 3 steps.
Okay. And actually, I can maybe show what happened here when we were waiting.
Good.
We switched to a new environment, and it's like the first time it takes longer than what we practiced. But anyway, so you'll see what I just ran is that you see those steps that Shelby just mentioned actually on the screen here. If you see it started, the one command actually goes through that for you automatically. We registered a model up there. Then it creates a manifest for you. It creates the image. This is the Docker image. And then it actually creates this service for you. And it provides you some commands you can execute right here on the command line to test it. So this service is actually up and running right now. So Shelby, you want to take over?
Yeah. So let me back up a little. So what I'm showing you here is the model management that I created in the Azure portal. As soon as I provision it, I have access to this view. And I can go ahead through my model management UI. I can go ahead and see the services as well as the manifests that have been created. In this particular case, there were 2 demo services that were deployed already. And the Iris one is the one that Jakub has gone ahead and that's the one that he just created.
It just happened 3 minutes ago.
3 minutes ago. All right, so I'm going to go back to the model that I created. I think my model is better than the version that Jakub has, so I'm going to go ahead and register my model under the same name as what Jakub registered. Like, as he mentioned, he gave one single command to go ahead and deploy the model into production, but what that did behind the scenes was it went through the same steps that I just walked you through, which is registered the model, it created a manifest, created an image, and then went ahead and did the deployment. All right, so I will go ahead and register my model now. And the command that I'm giving here is az model register. The -m is the path to my model file. And the -n is the name under which I would like to register this model. And just to justify why I'm creating a new version, I think I have better accuracy. All right, so we were able to successfully register this model. Let me do a list. And a prettier list.
Table.
Oops. So as you can see, we have 2 versions of the model picker. The first one, the version 1, is Jakub's version. We have the model ID that got generated. And version 2 is the one that I just went ahead and registered. Now my next step after this is going to be the creation of the manifest. And as I mentioned, all of the dependencies, including the model, the registered model, the code, as well as any other dependencies that I would like to add, is what goes into the manifest. That's my JSON file for, here's all the information that you need to go ahead and create that web service inside the Docker image. So I have my score file, my schema file, my runtime information. Am I missing anything, Jakub? I think I have it. Well, yeah, my model, the registered model.
Right.
So here I have my manifest already created. I'll do a quick list on the manifest. Just a prettier show. Here. So the first one, the version 1, is what came from the one single command that Jakub had for creation of the service. It created the manifest and the image behind the scenes. And then the next one, the version 2, is what I have gone ahead and created just now with that, the better version of my model. I did not have to change the scoring file. It was just the model change that I went ahead and did. The next step after this is the image creation. And in the image creation, I specify my manifest ID. And I'll go ahead and get the image creation started. Meanwhile, I want to take you into this the service that Jakub had created. So this service, it shows you that this service is serving the model.pkl version 1. And what we will see after the creation of the image and the service. So what's happening behind the scenes first, before I forget, in this particular case, this image is being created inside an Azure Container Registry. It's being created and it's going to be stored in the Azure Container Registry. And now this Azure Container Registry is part of a pre-created environment that we haven't shown you, but it's the machine learning compute environment that we have created as an extension to Azure Container Service. So that's where your images are being saved. I'll do a quick AZ ML usage, which let's just do a quick one over here. So this image now has my latest version of the model, and it has all of my dependency code. A quick usage command shows me how I can go ahead and either create a service using this Docker image, or I can go ahead and download this Docker image and I can deploy it to wherever I would like to go ahead and deploy it to, any Docker-supported environment. But for right now, I'll go ahead and use this to update the service that's already out there. The -I is where I provide the ID of the service. So I am asking to update the real-time web service, which has this particular ID, with the new image ID for the image that was just created. So it's the exact same service that Jakub had running. The new update is being rolled out as we speak, when it's going ahead and doing the service update with absolutely zero downtime. It's pulling the container image from the ACR, it's getting the service ready, it's rolling it out into production as we speak. That's the staging environment, as we're calling it in this demo.
If it takes a long time, we can always come back to it, perhaps.
We can give it a few minutes. Let's just...
Well, let it run right. Actually, while it's running, if there's a question or something about this, we can always address it quickly. It takes a few seconds. What it's actually doing is it's uploading this image to the registry, registering it, and then it will deploy it. So depending on the internet connection and so on, it goes faster or slower.
So I can talk about one other thing. Like,
right.
So we are waiting for the service to be deployed. The service is being updated. That's a service in staging. Another application of reusing your image is how, imagine in a real world scenario, somebody has gone ahead, registered the model, provided all of those dependencies, has a web service inside this Docker image. They've tested it out into staging. Staging is our current environment. And now they're happy with what they have. They would like to exactly use the same code and deploy it in production. So you can just pick that image, use that same image that was tested in the staging environment, and go ahead and deploy that in production. And your production could be like a bigger cluster, more nodes, more cores. So I have my second version of the image, the one that I created. I can go ahead, using the UI now, I can go ahead and create a service. I'll continue to use the same subscription, but I will switch the environment to be my prod environment. So this is where I picked the image from staging. It was tried and tested. I went ahead and used the same image to deploy into production. My earlier service is still being updated, but
That's okay. We can go on. We can come back when it's up.
so do we want to?
They go back to the presentation.
Yeah.
Oh, just go.
We should come back though to see the
Yeah,
registration.
we can come back to see it
let's go
working.
back to
Right,
that.
that's good.
So what we saw just now is the registration of the model, the creation of the manifest, the creation of the image, and then the deployment to our staging environment, a redeployment using that same image into the production environment. What you can also do by virtue of us betting on this Docker technology is you can take that image, deploy it to IoT Edge, you can deploy it to Azure Container Instances, or for that matter, you can deploy it to any Docker-supported environment that you prefer. Although we do provide you with the openness and the flexibility of deploying to these multiple targets, there are some special things that we are doing with our machine learning compute, the environment that we provide for you. We had talked a little bit about how scalability, latency, diagnostics are all very important. So the next demo is going to show you just that.
I'll go to your screen.
Hold on one second. OK, yeah, I have the service created. So let's, before we go to show you how we address latency and scalability, I'll just come back to the service. The service got created now. And I'm switching back to the UI. I went ahead and created the Iris SVC, which was picking up the same image. This is still Jakob's service, the Iris service that he had created. But what we have now is we have the image of the version, the newer image that I have created, the newer manifest that I went ahead and registered. And you can see here it's registered or it's using the new version of the model. So that's how we enable tracking of what web service, what images, what models are in production behind those web services. So one of the things that we also offer, since we are here at the UI, is integration with App Insights. So if you have App Insights turned on during deployment of your web service, you can directly go to your web services App Insights page. You can turn on notifications in case you want to monitor the health of your service. So that's the integration that we have done for the diagnostics, to handle the diagnostic scenario. Now I will quickly switch over to a demo that we have created. So what we have here is an image recognition service. This is deployed to ACS containers, and we have about 16 VMs in that ACS. I will go ahead and what we're going to show over here is how we handle scale and how we handle latency. So this particular experiment that we're going to run is going to slowly bump up the requests per second that are coming into this service. And what we are going to show you is how the pods or the replicas scale up to handle the latency and to provide the scalability such that the calls don't get dropped and we get a good success rate. I'll just... So on the right-hand side here, we have the number of replicas or the number of containers inside our cluster. Right now, we have our capability turned off. That's the autoscaler capability. And we have set this service to only have 3 pods serving at the same time. I'm going to use pods, replicas, and containers interchangeably. But it's essentially the number of containers that get spinned up or spinned down to address the calls that are coming in. The left side is the requests that are coming. You will see previously we had 100 requests per second for a few seconds. The success rate at that time was 100%. The success rate is being refreshed on every bump. And now we just bumped up the requests to about 200 requests per second. The red is your number of pods. So we still have about 3 pods, no scaling up of the pods, no spinning up of the pods. And with 200 RPS, our success rate kind of went down to 99.47. You'll see as we go to the 600 RPS, that's more number of calls coming, and the service not being able to handle it because we have a static set of pods. We're not doing any optimizations there. And that's with the autoscaler turned on. We can wait for this.
Can I go back to the presentation?
So just to give you a sense of what we have on top of ACS, we have the Azure Machine Learning model hosting cluster, a capability that bits that we add, the front end that we are adding on top of ACS, which is the model hosting front end. When the requests come in, we have these few components sitting there in the front end that handle, that do smart routing, that do auto-scaling, and auto-scaling is the demo that we're looking at over here. Right now, our auto-scaler is turned off. But essentially what these components do is they make themselves aware of the load that's coming in, and they optimize for low latency. They optimize for scalability. So the autoscaler is the one that spins the pods or the replicas up and down to handle the load in real time, such that fewer requests fall on the floor. At the same time, the router is the one that reroutes requests, looking at the load per pod. So yeah. So just coming back here, when we bumped to the requests per second up to 600 RPS, look at the success rate. The success rate has come drastically down to 28.94. And that's, again, that's just to show how bad the situation might get if we do not have control or the flexibility to be able to auto-scale the number of pods. And again, keep in mind, this is not the number of VMs that are going up and down. This is within that finite set of VMs. It's the containers that are spinning up and down, and that's what our web service, our services provide, not the web service, sorry. Yeah, I'll let it go.
You can just run it, right?
Maybe I should turn it back on. All right, so now I'm going to turn this autoscaler on. Let me just quickly refresh it to make sure. And these are the settings that you can do on the web service. These are configurable on the web service. Go ahead, provide the key again so we can get the experiment started. And now so we're starting off with the replica count of 3. We're going to follow the same graph. We're going to do the 100 RPS first, bump it up to 200, and then 600, and see how it reacts. You can see already that the replica counts have started going up at the 100 RPS. So we're being aggressive with making sure that we are able to serve those web service requests, or the calls that are coming into the web service, by keeping the pods up, spinning up more pods. So what we have set over here, the minimum number is set to 3. With the autoscaler on, we have the maximum number of replicas or containers set to 100. This becomes really important, like the autoscaler capability comes in really, really handy when you have n number of web services behind a single endpoint or behind a single ACS cluster. So it keeps all of the load for each of the web services in check, and it makes sure that everything is being optimized to, such that the surges in the traffic for those web services can be handled well.
Show the graph again.
Yeah. So we're still at 100. It's going to take about 2 minutes to get to each one of these. And just to give you a quick analogy. So it's almost like when we had the autoscaler off, we had, imagine Costco. We have the checkout counters. So we have only 2 of the checkout counters open. So regardless of the number of people that come to check out, if there's only 2 open, obviously it's going to be really, really hard to keep the latency low. It's going to be really, really hard to keep serving happy customers. So what the autoscaler does for you is it stands in front of all of those lines. Again, consider the Costco checkout. So there's somebody standing in front of those Costco checkout counters and saying, hey, the latency, or there might be more and more requests coming in. We're already full on these 2 backends or these 2 pods. Let's go ahead and spin up a few more. And again, this is a finite set of lines, but let's go ahead and spin up a few more such that when newer requests come in, we have a way to handle that. Keep the latency low and keep serving the requests, keep the success rate high. Now switching back to the graph here, we have bumped from 100 requests per second. We have gone up to 200 requests per second. And you can see how we're slowly scaling up. The red line, again, is the number of replicas or pods that's trying to keep up to speed with the requests that are coming in. Our success rate has dropped a little bit, but it's still pretty good. And we're at what's the replica count looking like?
We're at about 10 or so replicas.
Yeah.
Going to run for a while. So this runs for a while. What happens is because we keep monitoring the service and then reacting to it, so we have to run for a while and let it adjust it. Sorry, there's a question while it's running.
Yeah, just curious if there's an SLA on the success rate of the autoscaler function. If there's some sort of guarantee as to
we are really handing the knobs to you to be able to go figure out what the right, like to what extent you want to, how aggressive you want to be with scaling up or down the pods. Right now, we don't really have an SLA subscribed. But yeah, we'll be giving you all the knobs and levers, basically. There's settings that you can set, and you can do trial and error on it to see how well you handle it.
You can see that the rate went up to 600 right now. And you'll see
all right, so yeah, so the requests are now up at 600. Our success rate is still, yeah, that's still looking pretty good. Our replica count has maxed. But see, every time there is a surge in those requests per second, look how quickly the pods scale up to go try to handle that traffic and keep that latency in check. So that's the, I think that's a pretty cool thing that we're all very proud to deliver.
Okay, go back to the display. We can come back here. I'm going to wait for that one.
Yeah, I think we can wait for this to come back down. And you want to, the next one is
down.
the.
Okay. Let's come back on the intro, right? Any other questions on the autoscaler? Otherwise, I think we'll continue. We'll come back. This is there's more to this, and we'll show you later on what it does as the load changes. Go to the next page. All right, we're now getting to the other part of this. So we said we'll cover a variety of topics, right? About being able to deploy, being able to autoscale, being able to update your service, manage your service. A important task that data scientists have for real-life models is actually monitoring the models in production and deciding when is it time to retrain and change it, or monitoring if something goes wrong with a live service, especially data science service. So the particular scenario, we actually worked with an internal team. It's the Microsoft Store. These guys receive online transactions, and they have to evaluate those for fraud. And if you guys are familiar with the fraud and bank cards work, if you're an online store and you have what's called card not present transactions, if there's fraud on the account, you basically eat the loss, so that the bank doesn't lose it, the store loses the money. In addition, is even if you're selling digital goods, if you have more than a certain number of chargebacks, the banks kind of penalize you for having those chargebacks on accounts. So every online store needs to monitor its transactions and then score them for fraud. Now, fraud is a kind of adversarial game, right? The fraudsters are trying to outsmart the systems that are trying to catch the fraudsters. So they will try and change their tactics. And if you're the guy in charge of the fraud models, you want to monitor those data coming in and be aware if anything changes, if you need to change your model. Also, anything that might disrupt the normal transactions being served. So it's a very important scenario for doing, being able to monitor your model and adjust as necessary. So what we're going to show you right now, and if I can just get back to my screen here, which promptly fell asleep. Okay, we'll test worked. All right, so I'm looking at the portal again. So in this portal, you see that I have I have some resources. This is a cluster where I've deployed a fraud scoring model. This here is the model management account that Xavi has mentioned earlier. So what we've done here is we have a model that's actually running in this, and it's scoring data. What I want to show you is first just what the actual model looks like. So in our, this is the actual model that's deployed, the fraud model. You'll see we're looking at the init and the run, the same two type of services that you saw previously. What's different in this model is that there's this additional thing here called the model data collector. If you look at I don't want to get the highlight there. Let's go there, okay. So you'll see that the model data collector, we give it a name. We say, all right, this is it happens to be a random forest model. So we're collecting data on the random forest model. And we specify that we're collecting two types of data. We're collecting inputs and predictions, right? So we can collect any data set that appears as during the function of this model. What we then do is during the run method, you see the run method looks, again, it basically gets an instance coming in. It does the transform, which is the actual prediction of the scores. But there's two places we collect data. We collect that right on the input, And then once we've actually scored the model, we actually collect the output as well. So this means this is a live model in production. We're collecting this. I also need to say that this model is actually, it's a big data set. So the model is trained and executes in Spark. So this is a Spark model running on a cluster. All right. So let's look what this actually means. So if we go back to our model, this particular storage account that I've linked here, this is a storage account that's a part of the environment, the execution environment. And if you go into the blobs, you'll see that there's a container called model data. And if we click through some of the blobs in the model data, you'll see that there's a fraud risk. This is the name of my service. There's a folder kind of for the specific model, the RF model. And we have these inputs and predictions. So these are the two types that I'm asking to log. And if you go, this gets logged by date. And if we can go down to a particular date, and you'll see in there, you'll see this CSV file, which is the actual predictions being logged, right? All right, so if you're monitoring the data, you can just point some kind of a tool towards this to monitor the data. So what I've done here is I've actually created a Power BI dashboard. I'm pointing to this data set that's being collected. You can see here's all the fields that we're getting. So we're getting something like a timestamp and then all the input fields plus predictions. And let's look at this. This is a particular day, and we kind of cheated a little bit by artificially moving the data around, so to get a typical challenge for what data drift might be. So this shows you the kind of things that someone might be monitoring on a data, right? So for instance, on this model, we don't have actual outcomes because it's fraud. We're just seeing the data scoring predictions. So a very good kind of temperature of the model is to look at the distribution of scores, right? How many transactions score very high versus low. Fraud is a very rare occurrence. You typically get fraud only on a fraction of a % of transactions. So you're expecting most scores to be low with a small fraction of them being high. I'm actually looking here. I created a visualization on the scores just to see, like, how many scores do I get above 0.9. And this might be the type of transactions you decline or call the customer to see if you want to reject it, right? So this is the hour of the day, and we're looking also at the scores by different product types and by stores and the like, right? So in the morning hours, this was these 2 hours, we have about 2% scoring high, and you can see the distribution is mostly low. However, if we look at the afternoon, you'll see there's a big change, right? The score distribution is clearly different. So all of a sudden, we're getting a lot of high scores. You can see here in the high scoring bins, a lot of transactions. This would be like, for instance, you're a store, and all of a sudden you're declining a large fraction of your transactions, right? And I can promise you the business owner is going to be complaining about this. And if we look here at the data, you can see the difference here. This particular category here, risky digital, this is some classification we have, say, on the type of transactions or type of products we're selling. And all of a sudden the distribution there went, from just a few, we get a lot of transactions, a lot of the sales in that category. This might be something like a new product got released and it accidentally fell in that category, and it's a super hot product and everybody's buying it, right? So clearly, as a data scientist, I need to now kind of adjust my model, retrain to this new data distributions, right? Just want to show you, so because we can actually get the data, a typical task you would go to is I can now go to my data sources. I can create this data as a data source. I can point to it. I can bring this into my training environment. Something that you'll definitely use here is the ability to sample your data, right? I don't need to bring back this humongous data set that's been gathering with gigabytes of data. I can look at, say, only the top 2,000 to do my manipulation and preparation of the data. So I've brought in my data, and then I can create one of these data flows. I just want to mention, typically with, for instance, fraud detection, is you'll have a separate kind of system that collects your tags, right? These are customers that report this was fraud on their account, and you can identify the transactions that were fraudulent. So you might have a file like this that says, okay, here are some IDs of transactions that happen to be fraud, right? We can now create a data flow where what we're actually going to do is we're going to start with our two input data, the data and the frauds, And then we're going to join them, and we can show you like a typical join transaction. Again, very easy to do inside Dataflow. And the good thing here is that we're working on a small sample of the data. We're actually we're telling what we're going to do later on the big Spark cluster, right? So we've got our two data sets. We've defined 2 results, and you can see we've got the join. I'm basically taking all my data and I'm just matching with the fraud IDs that I know that in order to tag my data. And then after I've done this, I've done one of these derived by example to say, well, everywhere where I don't have a match, my tag is obviously non-fraud, otherwise my tag is fraud, right? And then finally, I just wrap it up by creating a nice label column. Okay, so this basically allows me to take this data that I can gather from the live service, match it up with some tags, and now I can actually submit a job to just do the retrain immediately, right? So if we go back here, we can say, I can go to my dashboard, and what I did is I took our train, actually I renamed this train 2. So exactly like I was previously training my data, I just now point my data to this retrain package that I have, and I can then go and I can say, let's take this new this job. I'll run this on a VM because this is a big Spark job, and I think I call this train 2, and I can just go ahead and say, okay, I submit this, and you see I've done it before. We'll submit this to run this, and essentially this allows you to then create a new model, and you can go through all the steps we previously saw to register that model and push it up into production as a new, a new production service. So I think the key message here is that, the fact that you can log your live model data as it comes in, you can look at it, monitor it, suck it in, and retrain really gives you that continuous update cycle that you require for live models. Alrighty, let's go back to the presentation. You want to go back to this one first?
Yeah, we can have a look at this. So the autoscaler experiment is done. You can see how the RPS went down from 600 all the way down, and the pods scaled back down all the way to the min replica count that we had set it to. So that's just the scale down, not keeping the pods up if the requests are not coming in. So that's the end of this graph. I think we can. So that was it, a quick recap of everything that we talked about. You saw how easy we still have. We have the ease of use of deployment this time through the CLI. We give you the choice of either leveraging our command line interface or the UI that you saw, the model management UI. We also have APIs that we provide to conduct the same operations like in an automated way. We talked about model management, the ability to track your web services and what models are being served behind those web services. We talked about the concept of registering your model, creating a manifest, building the image, and then going ahead and deploying the Docker-based web service to ACS. The Docker-based images, that enables deployment to multiple target destinations. We talked about the smart routing and the auto-scaling capabilities through our machine learning hosting infrastructure, and how we handle latency and scale through the autoscaler demo that we had. And Jakob just showed you how we can use the data collection capabilities to go ahead, create those data drift pattern recognition graphs, and then be able to react to those, bring that data back into our retraining framework, and go ahead and complete the whole loop of retraining the models, creating newer versions of those models, leveraging the version tracking to be able to now see what's the new version that's behind the production service. So that was it in terms of what we wanted to walk you through with you in this session. Right here, we have some QR codes for more details on Azure Machine Learning and the new services that we have released. We have a blog. Be sure to check that out. There's a lot of information in the blog as well as on the azure.com page about our new services. And
Great.
yeah,
Thank you. If there's any questions, we'll be happy to answer those right now. Any questions? Anybody? Yeah, sure.
So, excuse me if I'm just misinterpreted the last bit about the retraining.
Right.
But it wasn't clear whether that was fully automated. It seemed like there was some sort of manual effort there. Is sort of automated retraining of models something that's built
I think
in?
it's, well, let me start the first thing. So what we showed was basically the kind of like the building blocks that you require in order to do that, right? So the ability to monitor your model, the ability to suck in data and retrain, right? If you wanted to automate that, yeah, you would, I think, have to write some scripts around that in terms of...
So you'd write some scripts that would execute those commands.
To basically, because I think in general, you want to keep an eye on, when you do the retrain, validate that that the performance is what you want, that you've prepared your data correctly. But I think, since everything we show there can be scripted, you can kind of automate that process once you set it up, right?
Right. You may not want to, but you can.
Yeah.
Right. So right now we have the building blocks in place for you. So we're building on top of it as we move forward. But what we have provided to you is to be able to get there as of right now.
Right. Got it. Thank you.
Thanks. Okay, well, thank you, everyone. That's
Thank
it.
you.
Thanks for your staying up until 5 p.m. on Tuesday. Enjoy the rest of the show.